Welcome to this introduction to Chapter 4, Consumption and the Natural Rate of Interest. I'm Nils Gottfries, I'm the author of the book Macroeconomics. And this presentation is a brief overview of the chapter so as to prepare you for more careful studies of the topics in the chapter. And Chapter 4 continues the analysis of the demand side. We look at private consumption, which is about 50 to 70% of aggregate demand in rich countries. And to analyze consumption, we look at two extreme cases. We look first at a consumer who lives for two periods and makes a choice how much to consume in the first and the second period. And then we consider a consumer who lives forever and analyze the consumption choice of that consumer. And then we summarize what we have learned in the form of a consumption function, which you can think of as a rule for how much to consume in order to achieve maximum happiness. And then in this chapter we will also take the pieces that we have for demand and supply and put them together to a macro model in order to understand how the real interest rate is determined in equilibrium. And that equilibrium real interest rate, when production is on its natural level, is called the natural rate of interest. So consumption is between 50 and 70% of total demand, and it's highly correlated with GDP. So these graphs show the growth rates of real private consumption and real GDP in the UK and the US. You see a very close correlation. Of course, that reflects two things. One is that consumption is a very large part of demand, but also that income is an important factor that affects consumption. So, we consider first a consumer who lives for two periods, period 1 and period 2, and this consumer has income from work in the two periods, Y1L and Y2L. And the consumer enters the first period without any assets, and the consumer does not leave any bequest at the end of period 2. And we use A2 to denote the assets of the consumer at the beginning of period 2. And this is before you have received interest on those assets. And just like capital, assets are measured at the beginning of the period. So the consumer has a choice in period 1 between consuming now and saving so as to consume next period. And the real interest rate between the periods is R. And the consumer knows the incomes and the interest rate. There's no uncertainty about the future. And that means that savings in period 1 is the labor income that you have minus what you consume. Note that this can be a negative number, which means that you borrow. And next period, how much can you consume? Well, you have the income next period, and you have what you saved in the first period, and then also interest on those savings. So that determines consumption in period 2. If we substitute in the expression for savings in period 1, or that is the assets at the beginning of period 2, then we get the following expression for consumption in period 2. If you look at the right hand side, you see consumption in period 2 is equal to income in period 2 plus the income that you had in period 1 times 1 plus the interest rate minus the consumption that you had in period 1 times 1 plus the interest rate. So consumption in period 2 depends on incomes in both periods and how much was consumed in period 1. And we see here immediately if the consumer consumes one more unit in period 1, he must decrease the consumption in period 2 by 1 plus R units. So again, we see that 1 plus the real interest rate is the price of goods today in terms of goods in the future. And this equation can be written in another way that says that the present value of consumption over the whole life must be equal to the present value of income. So the present value of income is the income today plus the income tomorrow discounted to today. You remember that the discount factor is the conversion factor that you use to convert future income to a present value. And this is the consumer's intertemporal budget constraint or lifetime budget constraint. And we realize from this analysis that what determines consumption possibilities is not just income in one period or the other, it's the lifetime income of the consumer. That is the key determinant of consumption possibilities. And in the two-period case, we can illustrate this with a lifetime budget constraint. On the horizontal axis, we have consumption today. On the vertical axis, we have consumption next period. And the point A denotes the incomes that you get in the two periods, Y1L and Y2L, the labor incomes. And of course, you could choose to consume at that point. You consume your income in each period. But you can also choose to save some of that income in period 1. So suppose that consumption is C1 here. You consume less than your income in period 1. That will then allow you, according to the budget constraint, to consume more in period 2. And how much more? Well, the slope of this line is minus 1 plus r. So that means if you abstain from 1 unit of consumption in period 1, then you can increase consumption in period 2 by 1 plus r units. So this is the lifetime budget constraint. So to analyze the choice of the consumer, we also need preferences. And we assume that the utility that you maximize is U of C1 plus U of C2 divided by 1 plus rho, where U is an increasing function. So more consumption gives greater utility. We also assume that this is a concave function, that is, the slope is it gets flatter and flatter the more you increase the consumption, which is the same thing as saying that the marginal utility is decreasing. And that also means that the consumer prefers to have a smooth flow of consumption to an uneven flow of consumption. So those are the characteristics of the utility function. And rho is called the subjective discount rate. And we normally think it's a number bigger than 0, maybe 0.02 or something. And that reflects the idea that we value consumption in the next period less than consumption today. If rho is bigger than 0, then we value consumption in period 2 lower than consumption in period 1. So here we illustrate this utility function U, that it's increasing but with a declining slope. And the optimal choice of consumption is, as usual, just like when you choose between apples and oranges, you want the marginal rate of substitution to be equal to the relative price. Here you want the marginal rate of substitution to be equal to the relative price between consumption today and consumption in the next period. So it's the usual rule that the ratio between the marginal utilities should be equal to the ratio between the prices. The marginal utility of consumption in period 1 is U prime of C1. The marginal utility of consumption in period 2, as seen from period 1, is U prime of C2 divided by 1 plus rho. So that's the marginal rate of substitution. What about the relative price? Well, one way to see that is to look at the prices in terms of money today. The price of consumption in terms of money today is PT. The price of consumption next period in terms of money today is the price next period discounted to today with the interest rate. So divided by 1 plus the interest rate. So that is the relative price of consumption today compared to tomorrow. And that again we recognize as 1 plus the real interest rate. So the marginal rate of substitution should be equal to 1 plus the real interest rates. And this diagram illustrates the choice between consumption in the two periods. So we can also write this first order condition for consumption, which is sometimes also called the Euler equation. We can write it as the ratio of the utilities is equal to 1 plus r over 1 plus rho. So here we see immediately in this two-period model that if rho and r are equal, then the right-hand side is 1. And for the left-hand side to be 1, consumption must be the same in the two periods, so the consumer will consume the same amount in both periods. So we see that how you allocate consumption between the periods depends on the real interest rate and on how you value the future compared to today. Your subjective valuation of future consumption compared to today. Suppose, for example, that rho is bigger than r. What does that mean? It means that the consumer is more impatient than the market. The consumer discounts the future more than the market. The consumer values future consumption relatively little. In that case, the consumer will want to consume more now and less later. And you see that because the right-hand side in the equation will now be smaller than 1 if rho is bigger than r. The left-hand side must then also be smaller than 1. But since the marginal utility is a declining function, that means that consumption C1 must be bigger than C2. So you see how the consumption path over time depends on the real interest rate and on how consumers value the future. Now we turn to the consumer who lives forever. So here we have a lifetime utility. We are in one period and we look ahead and value consumption in the future, but again we discount future utility with 1 plus rho. And again we assume that the consumer knows future incomes, interest rates, and makes a consumption plan for all future periods. So again, the present value of income must be equal to the present value of consumption. Now the budget restriction in this case can be written as follows: that the assets that we bring with us to next period, they are equal to the income we have this period plus the assets that we have this period with interest minus what we consume. So that is what we bring with us to the next period. And the optimum condition for consumption, or the Euler equation, it's the same as before. It's just the same. The marginal rate of substitution should be equal to 1 plus the real interest rate. And you can actually, in this case, under certain conditions, calculate the optimal consumption, a function that gives us the optimal consumption. You can read about that in the book. And that function is a consumption function. So in the book you have a specific version of it. Here we just write it in general terms. And that shows us that consumption is driven by 4 variables. The income today, the expected future incomes, the real interest rate, and also the wealth or the assets that we have. And if we look at the theory more carefully in the book, we see that clearly the most important determinant of consumption is the future normal level of income. If what you think you will regularly have as income over the future, what Milton Friedman called the permanent income, that is clearly the most important determinant of your consumption. If you have some temporary income, for example you gain on a lottery, then the theory says that you should only consume a small part of that because you want to smooth consumption over time. And the optimal thing to do with a lottery gain is basically to put the money in the bank and consume the interest on the money. Similarly, if you have a lot of assets, the optimal thing is to consume the return, the real return on those assets. But for most people, of course, labor income is the main source of income. The interest rate, that's an empirical question, how much that affects consumption. Most estimates would suggest that interest rates have rather limited effects on consumption. But we would expect a negative effect. Okay, so now we have actually completed the building blocks of our first macroeconomic model. We have analyzed supply and demand in a closed economy without government. So our analysis of supply in chapter 2 determined the natural level of production. And our analysis of demand in chapters 3 and 4 has determined investment and consumption functions, which are kind of rules for how investment and consumption are determined. And now is the time to put demand and supply together. So the question is, what is the price that makes supply equal to demand? Well, it's the real interest rate. So in a long-run equilibrium, the real interest rate has to be such that demand equals the natural level of production. And we call that equilibrium interest rate the natural rate of interest. So remember that. The natural rate of interest is the real interest rate that makes aggregate demand equal to the natural level of production. And this is illustrated here. We have production on the horizontal axis and the real interest rate on the vertical axis. And we know that consumption and investment are negatively affected by the real interest rate. So this demand in the economy declines when the real interest rate increases. And then we have the natural level of production that we determined in chapter 2. And then there's a real interest rate that makes demand equal to the natural level of production, which in turn means that employment will be on its natural level and unemployment will be on its natural long-run equilibrium level. We can also think of this equation as saying that desired savings must equal desired investment, because we can define a savings function as income minus the consumption function. So instead of saying that y equals c plus I, we can say that savings equal investment. If desired investment is higher than desired saving, then demand for loans exceeds supply and the interest rate must increase. So that's another way of thinking of it, that the real interest rate is determined by the interplay between savings and investments when production is on its natural level. But let us return to the previous figure where we have demand and supply in the macroeconomy and where demand is negatively affected by the real interest rate. What happens if the real interest rate is too high? Well, then of course production and employment will be below the natural level, because firms will not produce if there is no demand for their products. And that means that they will also not hire so many workers, so unemployment will be above the natural level. And if instead the interest rate is below the natural level, then demand will be above the natural level, and production will be above the natural level, and there will be high employment, and that will put upward pressure on wages and prices, and there will be inflation in the economy. So if the interest rate is not on the right level, we will have either unnecessarily high unemployment or excess demand and inflation. So who is it that adjusts the real interest rate to the right level? Well, to make a long story short, in a modern economy, it's the central bank that determines the interest rate. We'll come back to that later when we discuss monetary policy. So in this chapter we learn that the main determinant of consumption is the lifetime income, the present value of current and future incomes. We found a first-order condition for optimal consumption choice that says that the marginal rate of substitution between consumption today and tomorrow should be equal to 1 plus the real interest rate. We noted that if the real interest rate is equal to the subjective discount rate, rho, then the consumer will optimally keep consumption constant over time. And we summarized what we have learned about consumption in terms of a consumption function, saying that consumption depends on 4 things: current income, expected future income, the real interest rate, and the assets that you have. And finally, we put supply and demand together, and we define the natural rate of interest as the real interest rate that makes aggregate demand equal to the natural level of production. So, good luck with your studies of Chapter 4 on consumption and the natural rate of interest.